Have you ever wondered what is going on inside someone's brain? Well, 3 billion people worldwide suffer from neurological conditions, so understanding the brain is more important than ever. And so that's why I'm going to explain how blasting a molecule with lasers and microwaves can be used to measure brain activity. So the first thing we do is we consider a molecule. This is a molecule, and these are its electrons, and these yellow lines are the different energy levels that the electrons can occupy. And then the first thing we do is we take our electron and we excite it with a laser, and we excite it from the ground state up to this excited state. But you'll notice that that state is not stable, and the system wants to relax. But you'll also notice that there's two relaxation pathways. There's this fast pathway on the left, and when it relaxes by this fast pathway, the molecule emits some light or some photons in a process called photoluminescence. Okay, and we can measure that really accurately. But then there's also this slow pathway on the right-hand side. You can see it's bouncing around these sub-levels, and when it relaxes via that pathway, there's no light emitted. But what's really important is the amount of light we get out, the photoluminescence. That depends on the overall relaxation rates of both the fast and the slow rate. Okay. So once we have measured this photoluminescence, that's when we introduce some microwaves to the system, okay? But not just any microwaves. These microwaves have just the right amount of energy so that you can excite between these two sub-levels, okay? And when that electron is hopping between these two levels, and when the hopping is happening, then the overall relaxation rate of the system changes, and we can measure that as a change in the photoluminescence. So we can tell when the hopping is happening based on the light that we get out, okay? So let's say we've got this hopping happening. Then we bring into our system a brain, and we bring it close to a neuron, for example. And when that neuron is active, it emits some magnetic field, and that magnetic field is actually big enough to shift this energy level down. So it changes where the energy level is. And so those microwaves that were causing the hopping between those two levels are no longer big enough to excite that transition anymore. So there's no hopping happening. And that corresponds to a change in the overall relaxation rate again, and that's a change in the light that we measure. Okay, so that is how we can tell when a neuron is active, and that is how you can use lasers, microwaves, and molecules to measure brain activity. Thank you very much.